Okay, okay. So, this is my second video in consonance with the first video that we have, the HCP. Those are concepts, and this time we are going to explain it through the use of packet tracer. Okay, so as we all know, on the slides that I gave you in the DHCP, basically there's a part there that the the way we are going to configure it one by one. Okay, so all we have to do is to understand this one and apply it in our packet tracer, right? Okay, so basically this is how we do it in packet tracer. But firstly, this will be the topology that we are going to use. Okay, so in this instance we have a router here. Okay, two routers, and we are going to elect this router to become the DHCP server. So this router will give out IP addresses in this network and in this network also. So prior to this one, I have already computed some of the addresses that we are going to use. But if you want to see how did we come up with the addresses, it looks like this. So we will be using CIDR and BLSM notation for maybe in the next activity. BLSM, CIDR is a precursor of the BLSM notation, so therefore we must understand how CIDR works. So CIDR is an classless interdomain routing, which is totally different from what we call subnetting. Okay, the subnetting, although uh, prior to studying or mastering the CIDR, you should master also the subnetting first. Okay, so that you have a full idea on how to segment one network address into a many network address. So what makes it different, what makes CIDR different from subnetting? Number one, because CIDR has prefixes. Okay, when we say prefixes, these are the number of bits consumed already in a particular address. Like for example, if we are referring to class A, so we have already consumed 8 bits from there. That's why it is N. It is labeled as N. So if it is class B, that will be 16. Therefore, it's n.n.h.h, and class C for n.n.n.h. So for each octet, you have already consumed those bits until the 24th. Okay, so that makes it a prefix to that particular address. So each prefix is also a subnet mask of that particular address. Like for example, if you are referring to /8, that is 255.0.0.0, 16 is 255.255.0.0, and /24 would be 255.255.255.0. Okay, in that manner we can control the number of bits that have been consumed in that particular network rather than using one address and wasting a lot of IP address like class A. So if you will be working on class A, only one address has 16,777,216 IP addresses, which is a lot of waste. That's why we have to perform any of the task, any of the computation or notation that we need to lessen the waste of our IP addresses. Number two, the CIDR is different from the subnetting because subnetting uses classful addressing. This one is classless, means it does not point to any of the classful addressing. Okay, so that means if it is not that, if it does not point to any classful addressing, it may not be a class A, class B, or class C, right? So as we know, the 10.15.100.0 may be a class A because this address, the first octet, belongs to the range of 1 to 126, right? So 10 is inside the range of 126, therefore it is considered as class A. But if you are going to notice that the subnet mask of this address is /24, that means 255.255.255.0, which is a subnet mask of a class C. So this contradicts the fact that a class A has a subnet mask of 255.255.255.0.0.0 rather than this one. So that makes this one as classless. Okay, so to further we're going to compute an example of how classless interdomain routing is computed here. Let's say, for example, we have 198.15.224.0/21, and we are going to create at least 50 subnets. So I have already taught you the 6 steps on how to subnet. Since CIDR is also a subnetting procedure, we have to follow the 6 steps also. But number one, since this is not a classful addressing, but still we need to plot out the binary value of these addresses so that we can identify where to stop and where to begin counting the number of bits to be borrowed. Okay, so 198.15.224.0, then we will look for the /21. That means that there are 21 bits have already consumed in this particular address, and what's left would be our own subnets. Okay, so since 198 is still /8, so it is under /21, and 15 is still under /21 because the first octet and the second octet adds up to 16 only. So we have to find the 21st. So if this is 16, 17, 18, 19, 20, and 21. So 16 plus 5 is 21. So from these bits here of your address cannot be used anymore. Okay, so I marked it here so that the 21st bit cannot be used, and the last bit from the third octet down to fourth octet still can be used. Now we are going to erase this one first. So in order for us to create 50 subnets as our requirement here, we have to borrow the bits. Okay, we have to borrow the bits. So take note, this portion here can never be used. This portion is still free bits. So how many bits are we going to borrow if we are going to create